After learning about the key features of graphs for 2 days, we're now going to take a day and just practice putting all of the different key features of a graph together. So we're going to walk through a few um, together, and then you're going to have some homework where you're practicing putting all the key features together and describing them on a graph as well. So zooming in on our first example here, we're going to start out and we're going to find the domain. Again, I think it's helpful to use color on these to help highlight the x-axis for different portions. The domain, you'll remember, is what the x values can be on the graph. So what are our x values stuck in between? We write it as an inequality. Sorry, I'm going to run out of room. We're going to write it as an inequality, and we're describing x. So x should be in the middle of our inequality. Looking at our x-axis, remember this is x. It starts over here at the solid dot. It can be all these x values, and then we'll notice at the far right side of the graph, it has this arrow on the end, so it's going to continue to the right forever. If we're writing this as an inequality, we would state the first x value that the graph can be. 1, 2, 3, 4, 5, 6 in the left direction, so it starts at -6. Because that is a solid dot at -6, I'm going to put a line underneath it. Then, as we continue to the right, it continues forever to the right. It's going up and up and up, but it's also going forever to the right. So we call that positive infinity. Please make sure when you write positive infinity, you do not put a line underneath your inequality sign. You can't include infinity. Let's do the same thing for our range, except now we're looking at the y-axis. Remember the y-axis goes up and down, so you should have a y inequality, and you start at the bottom where the graph starts and continue up. The y value where the graph starts is down here at this y value. 1, 2, 3, 4, 5. -5. Since it's a solid dot, we will put a line underneath it. It continues up, and if we look at that far right arrow, it's saying it goes up and up and up and up forever, which when it goes up forever, we of course call that infinity. Just like before, do not put a line underneath that inequality sign. The next key feature we're going to describe are the x-intercepts. Remember, that is where the graph crosses the x-axis or touches. You should have 1, 2, 3 x-intercepts. Please remember that we write these as ordered pairs. So you have 3 different ordered pairs to describe your x-intercepts. 1, 2, 3, 4, 5 to the left, so that's -5, 0. 1, 2 to the right, so that's 2, 0, and 3, 4, 5, 6, 0. Those are your 3 x-intercepts. Similarly, the y-intercepts, let's check those out, see where the graph crosses the y-axis. 1, 2, 3, 4, 5. Write that as an ordered pair, 0, 5. You'll remember from yesterday that the positive portion of the graph is the portion of the graph where the graph is above the x-axis. So let's look at our graph and find where it is above the x-axis. You should have this portion here and this portion here. Because we just highlighted 2 different sections, you should have 2 different inequalities. You'll write them both in terms of x. This left section, count over to the left, 1, 2, 3, 4, 5, starts at -5, and it continues, the graph continues to be positive until this next x value of +2. It then picks up and is positive again in this far right section. That x value where it picks up and is positive is 1, 2, 3, 4, 5, 6. And then it continues up, but it also continues to the right. Remember, to the right is what the x values are how we describe the x values. And those are going toward positive infinity. The negative portion of the graph is where the graph is below the x-axis. So we have this portion here and this portion here. We will also write those in terms of x, and there are 2 different regions, so you should write 2 different inequalities. It starts at 1, 2, 3, 4, 5, 6, -6, and continues until this next x value of -5. It picks up being negative again, and between +2 and 6. Pause and rewatch that if you're confused about anything with positive and negative. Increasing and decreasing portions of the graph are where the graph is going uphill with a positive slope versus downhill, decreasing with a negative slope. The first thing I'm going to do is highlight the area of the graph where it is increasing. You'll notice that it is increasing or has a positive slope in two different regions. So set up your two different inequalities. Remember that we do this in terms of x as well. So the graph begins to be increasing at this far left point. Go up to the x-axis and see what that x-axis value is. -6. It continues to be increasing to this point. So in between -6 and -2. It then is decreasing, which we'll fill in a minute, but it continues to be increasing from here, which is an x value of 4. And then as it goes on, you'll see that the arrow goes up, but it's also going forever to the right, so we call that forever to the right positive infinity. Let's do the same thing, but talk about the decreasing portion of the graph. The decreasing portion of the graph occurs in that section in between, where it looks like it's falling downhill. Well, since it's just one section, you should have only one inequality. Starts at -2, continues to 4. The next key feature we're going to fill in is the end behavior. Remember, with end behavior, you only talk about it for where the graph has an arrow on the end. So for example, this left side of the graph, see how it has a point there? We don't talk about the end behavior of that. It's not approaching infinity or negative infinity. On the right side of the graph, we will talk about this portion. So on the right side of the graph, where are the x values going? The x values are going to the right. So we would say, as x approaches infinity, we're then going to say what the y values do. F of x approaches, and then you say whether they're going toward infinity or negative infinity. Since they're going up, they're going toward positive infinity. The last thing we're going to talk about are minimums and maximums. Let's look for the maximum part of our graph. That maximum occurs at -2, 1, 2, 3, 4, 5, 6, 7. You need to write whether it is an absolute maximum or a relative maximum. Now, if you look to the right of this graph, you'll notice that the arrows are saying it goes up forever and ever. So this is not an absolute maximum, it is a relative maximum. Let's look at the minimums. We have a minimum here and a minimum here. At -6, -5, that is the lowest part of the graph, so you should call it an absolute minimum. And then at the point 1, 2, 3, 4, 1, 2, 3, 4, 4, -4, because it's not the lowest point on the graph, but it is the lowest point around, we would call that a relative minimum. Pause and rewatch if any of those concepts might have been confusing. We'll continue practicing them down below. On the graph down below, we'll start out finding the domain. Write an inequality to describe what those x values are stuck in between. Check your work and the answer above. You'll notice that at -9, I put a line underneath the inequality sign because it includes -9. The graph then stretches all the way to the x values of 7, but doesn't include 7 because it is an open bubble. Find the range by looking at what the y values are stuck in between. Write your range with an inequality. Make sure that y is in between, in the middle. The smallest y value should go on the left, your y value of -5. It should not have an inequality sign, a line underneath the inequality sign because it is an open bubble. The graph continues on to 8. The highest y value stops at 8, and it includes it because it's a solid bubble, so put a line underneath it. Please write your x and y intercepts as ordered pairs. We will check those in a minute. You should have found that your x-intercept occurred at 4, 0. Your y-intercept occurred at 0, 3. If you just write the plain number, you will not get credit, so please make sure that you write them as ordered pairs. Let's now take a look at the positive and negative regions of the graph. Positive is the area where the graph is above the x-axis. So if you are able to, highlight the region of the graph that is above the x-axis. Negative region is where it is below the x-axis. Highlight that if you are able. Now describe in terms of x the areas where the graph is positive. You should have found that the positive regions of the graph occur in between -9 over here and +4. The negative regions of the graph start at 4 and extend to 7. Let's now check out the increasing versus decreasing portions of the graph. Increasing, where the graph is going uphill, versus decreasing, where the graph is falling and has a negative slope. Even though this portion on the right has like different negative slopes, it's all falling. It's all decreasing. So we'll group that as one whole segment. Still write it in terms of x. It starts increasing at an x value of -9 and stops at -6. It then starts falling. So our decreasing portion should start at -6 and continue to 1, 2, 3, 4, 5, 6, 7. Last piece asks us to find the end behavior. Can we find the end behavior here? The answer in your head should be no. You must have arrows in order to describe end behavior. We will go over one more example together, flip to the back. Just a little spoiler alert, this graph on the back is actually a sine graph, which you'll learn about when you get to pre-calculus, when y'all are either juniors or seniors. Take a second and find the domain and range on your own. The x's extend forever to the left and forever to the right, so we would say that that is -infinity to positive infinity. The range, based upon what y'all know about this graph, since it has arrows on the end going up and down forever, y'all can say it goes from -infinity to positive infinity. Using the graph, write your x and y intercepts that are shown. We'll check those in a second. Your y-intercept is 0, 0. Your x-intercept, negative 8, 0, negative 4, 0, 0, 0, 4, 0, and 8, 0. Now let's find the positive portions of the graph and the negative portions of the graph. There should be 3 inequalities for each. Go ahead and set those up. Try to fill those in. Check your work once you've finished. Do the same thing for the negative portions of the graph. There are 3 portions where the graph is negative, so set up 3 different inequalities. Check your work. Make sure, common error over here, on this left side, I know that the graph is going down. It's also going left. That's going in terms of x to negative infinity. Let's now try the increasing versus the decreasing portions of the graph. Increasing, graph is going up. Decreasing, the graph is falling. Still write them in terms of x. Give yourself a second and fill in those inequalities. Check yourself once you've finished. Do the same thing for the decreasing portions of the graph. Try it on your own first and then check your work. For the maximum, we have 2 maximum points on the graph. Because we're assuming that this graph continues upward, these would be relative maximums. List those points for maximum. Similarly, these 2 points down at the low part of the graph, we would list as relative minimums. Go ahead and fill those in for minimums and maximums. The last thing we're going to describe is the end behavior. I didn't put it on there, so we're just going to write it out. On the left side of the graph, there's an arrow. On the left side of the graph, what are those x's going towards? In terms of x, they are going towards negative infinity. The y's are approaching, well, they're going down, so we'd also say negative infinity. On the right side of the graph, x is going towards positive infinity. Let's describe what's happening to the y's. As x gets larger, as these x numbers get larger to the right, the graph is going up and up. We would say that it's approaching positive infinity. On your homework, you'll be practicing putting all the key features together just like we did on our notes. Make sure that you're trying all the problems and coming back to your notes if you have any questions.